In search of a world easier to live in, we humans continue to evolve every day. However, global warming due to climate change is progressing, and many issues, such as environmental pollution and destruction, are growing worse on a global scale. What can we do to pass on our shining blue Earth to the next generation? There is an international prize presented to individuals and organizations that have made significant contributions towards the solution of global environmental problems. The Blue Planet Prize was established by the Asahi Glass Foundation in 1992. 2 laureates have been selected each year from a wide range of fields to honor their achievements. In October 2023, the 32nd Blue Planet Prize was awarded to 1 team of scientists and to 1 individual scientist. The team of scientists is from the United Kingdom. 3 scientists have played an important role in alerting the international community to the dangers of marine microplastic pollution and influencing policymaking in countries around the world. This research and the scientists' promotional efforts led to an agreement at the United Nations to work on reducing plastic waste.
We can only move towards more sustainable use of plastics by working together across industry, across policy, across society, across academia. Ladies and gentlemen, distinguished guests, we only have 1 blue planet.
The other recipient is Professor Devarati Guha-Sapir, who was born in India and now lives in Belgium. The professor led the development of the world's first international database on large-scale disasters. It's now used by many international organizations and national governments to address disaster prevention and mitigation, and also serves as the source for the scientific data that is essential for climate change policies.
My research aims to find practical, data-based solutions to protect high-risk communities from effects of such events. Being awarded the Blue Planet Prize provides me with an extraordinary opportunity, but also with a responsibility.
Reviewing the careers and achievements of the prize laureates, we will look to the future of the global environment. Plymouth is a port city in Devon, southwest England.
It's been brought by the sea, by the last high tide, and probably it's the sea that's brought these. The rate of entry to the environment is very fast, and so what we need to do is to stop. I'm most concerned to stop more plastic going into the environment.
Professor Richard Thompson, Professor Tamara Galloway, and Professor Penelope Lindeque are all from the United Kingdom. They have been pressing the world to acknowledge the dangers of marine pollution caused by tiny pieces of plastic called microplastics. Their research demonstrated that these substances are widely spread in the ecosystem via zooplankton, and this led to a global movement for countermeasures. Professor Richard Thompson was born in Nottingham, central England. During family vacations to the ocean and lakes, he nurtured an interest in water and the creatures living in it.
So there's always been this kind of strong connection with the environment and water particularly. Going out with a little net, trying to see what I could find in some of the lakes that were quite near to the house or the river, and then I started fishing. So there's always been this interest, I think. And
he went on to study marine biology at the University of Newcastle. He later moved his research base to the University of Plymouth and discovered something while picking up litter on the beach in between his studies.
I was working on beaches a bit like this for my studies, and I could see the litter every day in my experiments, that things I had to come to study every day, and I would take it away, and the next day there would be more. It just got me curious. I mean, I'm training to be a scientist, and I'm asking questions, and I'm thinking, where's it all coming from?
He immediately began his investigation, and further questions emerged.
I realized we were walking over many, many small pieces. They were not being collected, and it got me curious, because to me, that was the most abundant. The most common was these very small. And so I started to formulate this question, what are the smallest pieces of plastic?
He gradually discovered that plastics are broken down into smaller pieces by wind, waves, and ultraviolet rays, and they drift in huge quantities in the ocean.
You know, any interesting answer leads you on, I think, to the next question. Where does it go? Is it just on the beaches? Is it in the other sediments? You know, also then, well, who eats it?
Professor Thompson defines items smaller than 5 millimeters as microplastics. When he published a paper on microplastics in 2004, it set alarm bells ringing around the world as an issue that had previously been generally unnoticed. As a new research field emerged, many scientists began applying their expertise to work on it. Marine ecologist Professor Penelope Lindeque is one of them. Surrounded from a young age by a family with a deep appreciation for nature, she went on to pursue a career in marine ecology. While pursuing her academic studies at the University of Bath, Professor Lindeque became particularly interested in zooplankton.
I was amazed to know that even though they were so small, they're some of the most numerous animals on our planet, and they're really, really important.
Professor Lindeque began studying the ingestion of microplastics by zooplankton.
We realise that once they're in the marine environment for a little bit longer, they become aged, they develop a biofilm, and actually the chemistry of that emits a signal, a chemical ecological signal, that actually makes the plastics more tasty.
Professor Lindeque is currently continuing her research on the effects of microplastics on zooplankton at the Plymouth Marine Laboratory.
We're going to do a net trawl today to fish for zooplankton and also to get some material to see if there's microplastics in it. Some of them are moving really quickly, and some of them are a little bit bigger. And these are the type of animals that we've been doing our experiments on.
In the course of her research, Professor Lindeque succeeded in capturing some remarkable images. This is a video of zooplankton which have ingested microplastics labeled with fluorescent dyes. It's clear that the microplastics are moving inside the body.
With regards to when we knew that microplastics were a pollutant, we were the first to actually demonstrate that they were being ingested and subsequently had an impact on the zooplankton. And I think some of that visual footage has been really crucial in raising the awareness.
How do microplastics ingested by zooplankton and other organisms affect ecosystems? Professor Tamara Galloway of the University of Exeter is conducting research on this. She went to the University of Glasgow in Scotland at the age of 16 to study biochemistry. Later, At the University of Edinburgh, she continued her research on the effects of environmental pollutants on living organisms and became an authority on ecotoxicology. Professor Galloway investigated how microplastics affect zooplankton that ingest them. As a result, it's become clear that zooplankton are being endangered by their feeding behavior.
They pass through the gut, but they can't be degraded, but they are a physical presence. So they can, one of the things that they can do is that they can block the gut, they can damage the gut, they can fill the gut up so that the organism doesn't realise that it's hungry anymore, something that we call false satiation.
The inability of zooplankton to obtain sufficient nutrients for growth has had a major impact on the ecosystem, such as decreased reproductive rates. In addition, the reality that microplastic pollution is spreading through the food chain to a wide variety of organisms has also become apparent.
And we do know that all the layers of the food web are contaminated. We studied the organisms that eat them, we studied the fish, we studied the marine turtles, we studied seals and dolphins, and we find microplastics in all of them. So we know that all of them are exposed.
Amid concerns about their spread throughout the ecosystem, the use of plastics is increasing year by year. Currently, we produce 400 million tons of plastics annually, 40% of which is single-use.
So what do you just stop there and say, well, it's all a disaster, we'll stop? No, you have to try and find out what those solutions are.
One location where the team seeks a solution is the equatorial Galapagos Islands in the Pacific Ocean. Even here, in this treasure house of fauna and flora, with an unspoiled natural world, plastic waste has become a serious problem. At the request of the Ecuadorian government, a project team including Professors Galloway and Lindeque has been working on an initiative on this island as they simultaneously coordinate beach cleanup activities.
Can we work with the islanders to find things that they use as waste products that they could use to make plastics that would then biodegrade back down into the local environment and eliminate all of those waste products?
The team is working on how to utilize waste sources such as banana peels and seashells. If they can create plastics that biodegrade naturally in the environment, it will help solve the problem of plastic waste. Research has already begun on how to collect microplastics in the ocean. Professor Lindeque is taking the lead on this project.
So we have a header tank, and in that, each week will be the plastics.
This research is about using bivalves like mussels, which ingest microplastics as natural filters for plastic collection.
So we were really keen to try and investigate whether we could use mussels as a nature-based solution to remove microplastics. And to start with, we just designed a flume tank, and we had mussels in there under flowing water, and to see how many microplastics they could remove from flowing water, which very much mimics your sort of coastal environment.
Amazingly, 1 kilogram of mussels can filter out and excrete 250,000 pieces of microplastics per hour. The research is an attempt to remove microplastics by collecting the feces of these bivalves. However, these efforts have their limits. Aiming for an ultimate solution, the three scientists have actively appealed for the overall reduction of plastic consumption.
Consumers are going to be a key part, and we're going to need to step up to the challenge. We're going to need to try and use less plastic, and of course we can try to do that.
Yet perversely, microplastic pollution is spreading everywhere, not just in the ocean. Emissions arise from everyday products and have included microbeads in cosmetics, as well as clothing fibers and car tires, which are then released into the environment. Even found near the summit of Mount Everest, they are omnipresent worldwide, invisibly traversing both human and natural pathways. The three scientists' efforts have led to the enactment of laws banning products containing microbeads in the United Kingdom, Canada, and other countries.
There is a lot we can do, but I think we need to be aware that every little bit is actually going to collectively make a bigger difference.
Somewhere in this madness, we've got to stop and think about what it is that we're doing and what it is that we're throwing away, and how we can change that model and go back to a more sustainable way of living.
And so I guess what I'd like to hope is, from the crisis around plastics, is that learning to use plastics more responsibly could perhaps become an exemplar that we could then apply to other environmental crises, including climate change or other things that are on the horizon that we're yet to see.
Every year, about 160 million people around the world are affected by natural disasters. Today, the numbers of both disasters and disaster victims are 3 times what they were in the 1970s. One scientist is trying to record the details of the damage caused by those disasters to use the data for future disaster prevention measures.
This was a study on very catastrophic floods in Belgium, where about 40 people died. And what I think is important to say is that these are areas that are known to be high flood risk. Then why were people living there? So for us, it's really to influence policy, to change policy in a way that we don't have more deaths. That will be my goal.
That professor is Devarati Guha-Sapir from the Catholic University of Louvain. She created EMDAD, an international database of large-scale disasters that analyzes disasters from various perspectives. It was the foundation for a scientific database that is indispensable for disaster prevention and mitigation policy planning. Professor Guha-Sapir was born in Rourkela, a city in eastern India. Since ancient times, the region has suffered many natural disasters.
What were the two most important events that had a mark on my life? One was extreme heat, and also there were huge floods. There were people sitting in water. This is not for a country. You know, we have to have better development. And I thought, this is it. This is what I want to do. I want to do something that will make a difference to India.
After studying at the local University of Calcutta, she received a scholarship to attend Johns Hopkins University in the United States. At university, she studied epidemiology.
Johns Hopkins was one of the finest schools of public health. Very avant-garde, you know, very in the front line. I really wanted to be a scientist. I wanted to analyze the bigger problems.
At the university, she met someone who would drastically change her life. André Sapir from Belgium was studying for his master's degree in economics. They married 2 years after meeting, and in 1984, the couple left the US to move to Belgium, her husband's homeland. In Belgium, she became a researcher at the Center for Research on the Epidemiology of Disasters in Brussels. The first major assignment given to her there was to survey the African continent, where widespread and prolonged drought was causing famine.
And at that time, there were big famines in Africa, 1984. They used to work on famines, and they wanted me to come and work on famines. So that's why they offered me this professorship.
In African countries such as Chad, children were becoming severely malnourished. Upon returning to Belgium, she reported to her superior the dire situation she had witnessed in Africa. The words of director Michel Lechat at that time would have a great impact on her later life.
When I came back here and I debriefed with Michel Lechat, I told him, yes, well, he said, well, you know, what is the rate of malnutrition or rate of mortality rate, deaths, how many people are dying? And I told him something like, oh, there are many people dying, many people died. And he said, many? What does many mean? Many is a nonsense term. You have to bring me a number. Without a number, many people are dying. It's not good enough for science.
Without accurate data, it's not science. Professor Guha-Sapir fully realized the importance of capturing disaster-related damage in data form and reviewing it objectively. Her husband, André, sensed that his wife had a new goal in Africa.
But in that day, because also it was the first time that she went to these difficult conditions in Africa, I remember I went to get her at the airport, and I expected to see her a bit depressed. And she told me, she didn't tell me about all the awful stuff. She told me about where there was sort of a glimmer of hope and of positive element.
The professor's scope of information gathering was becoming more and more global, beginning with Africa, then spreading to Europe and Asia. And then the Emergency Events Database, or EMDAD, was released in 1988. The number of disasters for which data has been collected now exceeds 22,000 from 184 countries.
Each record, each disaster has three parts. And the first part is the physical characteristics of the event. Then we have the human characteristics. How many people have died, how many people are injured, how many people are affected, how many people are homeless. So we have the human impact. And then the third group is economic impact. So what has been the damages that have been incurred? Which sectors, whether it's agricultural sector or the road and infrastructure and so on and so forth.
EMDAD is open to the public so that anyone in the world can access it. In disaster-prone countries like Cambodia and Mozambique, civic groups have analyzed EMDAD data and used it for countermeasures, such as identifying high-risk areas.
Aid must be given on the basis of rational decision-making. And rational decision-making in most cases require objective quantifiable data. Earthquakes is a very good example, and I won't go into that example, but it's a very good example. Some people fall ill, some people die of earthquake, some people don't. So what do epidemiologists do? They try to see how are the people who die from an earthquake, how are they different? They are all in the same place, but some people die, some people don't. I think it's important to analyze natural disasters.
EMDAD is a valuable source of information for effective disaster prevention measures, especially for developing countries that cannot spend sufficient funds on surveys. And disaster data has also been used in the professor's hometown, where she repeatedly experienced disasters as a child. The 2011 floods in the Indian state of Odisha displaced more than 2 million people. The professor visited the area and conducted a thorough survey of the damage as well as the background of the victims.
We did field studies, for example, in the floods of Orissa, where I grew up. And they found actually that if the mother has at least primary school education, not even secondary school, primary school education, her children are much better protected from flood impact, yes. You know, I think if you have a little bit of education, then you can understand messages, communications, disaster much better. The government program actually took this result and put it into their program in trying to get mothers in the community who have some education to help the mothers who did not.
Furthermore, MDAT has become increasingly influential in building consensus among nations, transcending national limitations. The scientific and reliable MDAT data has also been used in the IPCC special reports for analyses of extreme weather events. Disasters are now showing significant changes on a global scale. The professor is concerned about disasters caused by climate change.
To the point that in the last 5 years, maybe 8 years, the share of climate disasters has now become between 85 and 90% of all disasters. Now, this is a very important factor. So climate extremes are becoming more frequent and they are becoming more severe.
In analysing the data for the past decade, a particularly sharp increase in the rate of flooding has been noticed.
It's a very simple graph. So we see here that 43% of all the disasters, 43% are in fact floods. So that's nearly a half of all natural disasters. To me, that's the biggest risk.
How can we prepare for floods and other disasters brought about by climate change? It's crucial that we take further countermeasures by leveraging the accumulated data.
We are at COP28 now. If for all these years, we are not seeing big successes. So we have to focus on adaptation. We have to help people to adapt to what is coming in the next 20 years.
Each and every one of us is responsible for the environmental problems that we have brought about. And the frequent disasters that occur in various parts of the world are never just someone else's problem. What is required of us now is to take a deep look at the crisis facing our blue planet and take action. This program was made possible by the Asahi Glass Foundation.